Well, here we go. Toss time once again. MS will spin. Heads is the call.
So who do you think will win this toss? Now, since we have already watched this match, we know the result, right? But at the moment when the coin is in the air, at this point of time, can you predict who will win the toss? No, you can't. There is a half a chance that MS Dhoni will win the toss, but there is half a chance that Sangakkara will win the toss. Now this chance, if you put it in mathematical terms, that is what is called probability. Hi, welcome to Ask IITians. My name is Sunil Kumar. I am a graduate from IIT Kharagpur and I have been associated with Ask IITians as an in-house faculty for mathematics. Probability is the mathematics of chance. Now in all such cases where you have flipping of a coin, rolling of a die, or pulling out a random card from the deck of cards, or any event in which you have the understanding that it might happen or it might not happen, wherever the term chance is used, if we interpret it in mathematical terms, it is what is called probability. Now let's look into our video lecture 1. In this, we will define probability, the basic norms, and how we calculate probability. What are the basic steps required? So let's get into the lecture and watch the video. Hi, welcome to probability. Now in this lecture, we will try and understand what probability means. Probability is the mathematics of chance. In any general term, if you use that that there is a chance of a certain thing happening or there is a chance of certain thing not happening, if we calculate it using a mathematical notations, it becomes probability. Or vice versa, we can say that probability defines every chance in mathematical terms. Now to understand this more deeply, let's look into our lecture. Now, as I just defined, probability is the mathematics of chance. So let's say, like we saw in this video, that when the coin was in the air, who will win the toss, right? So toss of coin is chance, right? Which has 50% chance of either team winning, right? Similarly, we can look into when a die is rolled, right? The chance of any particular number you want to occur, that is also called probability. Similarly, when a deck of cards is shuffled, okay, let's say at random you pick out any card. What is the chance that it will be a red card or it will be of a particular suit? So calculating the mathematics of all these things is called probability, right? Deck of cards. Similar to this, there are other cases, right? When I take multiples of coins or die or decks, right? When we combine them, they become a little bit more intrusive or complicated or complex. That is why we need to understand that probability is the complete form of application of any mathematics. Till now, whatever we have learned, we need to just apply in the logic of probability. That is what we are going to do in the whole chapter. Now, let's look into the first case that I had discussed. This is rolling of a die. Let's say when a die is rolled like this, you see 5 is coming. But it may so happen that at a different case, a different number is coming. So the probability of any such number coming out would be, let's say there are 6 numbers, right? So the probability of any of these numbers coming is 1 by 6. Why? There are 6 possible cases that can happen, but out of which always 1 will occur. So that is what is called the calculating the probability in this term. Now, for more details, let's say these are some cards, okay? Now, a deck of cards contains 52 cards. okay, 13 each of 4 suits, okay, so that makes it 52. Now in these 13 cards, okay, there are 3 face cards. Alright, that is king, queen and jack. Out of other, then there is one ace, and then 2 to 10 are number cards. Okay, now this ace is also considered as a number card. So let's say if there is a particular case that at random from a well shuffled deck of cards you pick out one random card. What is the probability that it is a black colored card? Now out of these 4 suits, 2 are black and 2 are red. Okay, like we have diamond, that is of red color, then we have this hearts over here, which is again red. This is the red team. Then in black that we have clubs, okay, and then we have a spade. Okay, these are all black. Okay, so picking the probability of cards is fun because there are so many variations that it can have. We will always have a new thing coming up in cards. Alright, now let's look into our basic definitions. Probability is the mathematics of chance, as I have just explained it to you. Then it tells us the relative frequency with which we can expect an event to occur. Now the relative frequency with which we can expect a particular event to occur. Now when we are rolling a die, okay, when let's say a particular number is coming, let's say 5 is coming, the showing of 5 when a die is rolled is called an event. Okay, similarly when we pull out a card from the deck of cards, that is also an event. Similarly when we are flipping a coin for the toss, whatever comes down, that is also an event. Okay, so the operation and whatever happens, that is called the event of the probability. Now, the greater the probability, the more likely the event will occur. If there, let's say there is a 70% chance of winning, right, means it is on the higher end of winning, right? So similarly, if there is a 30% chance of winning, then it is in the lesser end. Alright, so the greater the probability, the more likely the event that will occur. Similarly, it can be written as fractions, decimals, percentage or ratio. Most cases we use fractions and ratios. Okay, decimals and percentage are lesser used, but they are equally the same. Okay, now let's come to a little bit more into the deep parts of probability. Probability is the numerical measure of likelihood of a particular event, as I have just discussed, that it will occur. Then it is valued between 0 to 1. Now this is the mathematical part that you need to understand. Okay, any probability, take out any probability, its value will be from 0 to 1. Okay, it cannot be greater than 1, it cannot be lesser than 0. Okay, why? For a particular thing to happen, the thing is either it will happen or it will not happen, right? So if it is happening, then it is 1. If it is not happening, then it becomes 0. And from 0.1 to 0.9999, these are the chance that whether or not the event will occur or not. Okay, so the sum of all the probabilities of all the events for a particular case is always 1. Okay, now let's look into this graph that I have just explained. You see, when the probability comes to be 1, that it is certain that it will occur, okay, that the event will occur, okay, and when it is becomes 0, it is impossible. Similarly, 0.5 is a 50-50% chance. Okay, like flipping of a coin, that is a 50-50 chance, right? And all the probability will lie from this to this. This comes to the more likely part of particular event, and in this region it is less likely. Okay, so this is how probability is defined on a whole. Moving on. Now, a probability experiment is an action through which specific results like counting, measurements or responses are obtained. Now, the result of a single trial of a probability experiment is an outcome. Okay, these are the basic definition that you need to just understand. You need not memorize it, but you just need to understand what they are saying. Okay. Similarly, the set of all possible outcomes of a probability experiment in the sample space denoted as S. Example, all 6 faces of a die is this. Now, all possible outcomes gives us the sample space. Sample space basically means what is the maximum that can occur. Okay, that is the important part in understanding probability. Now, the chance defines that there is a particular percentage that will occur from the whole of the possibilities. The combining of all the possibilities is called the sample space. Sample space is also important because when, let's say, these are the 6, right? When we are denoting probability in fractions, this denominator is called the sample space. Okay, and this is number of possible events. Okay, sample space and possible events. Alright, so that is how we generally define it. Now, other examples of sample spaces may include listing, tables, grids, Venn diagram, trees, etc. There are n number of diagrams through which we can understand this. Now, we can use a combination of these to define that. Now, when appropriate, we always should display our sample space. Like whenever a die is rolled, you should always mention that the sample space of rolling a die is 1, 2, 3, 4, 5, 6. Okay, so in that case, what your logic at least is quite clear. Alright, so we should always practice using that. Okay, now an event consists of one or more outcomes and is a subset of the sample space. Alright, whatever the event is occurring, okay, whichever event that is occurring, that is the numerator of the part, that is always a subset, right? If the sample space, if we take the whole set of sample space, the occurrence of the event will always be a subset, right? Now, when an events are often represented by uppercase letters, okay, these are basic norms that you need to follow. Now, the probability of a particular event E will always be written as this. Now, this has to be followed. Okay, if I write probability of getting ahead, I will always write PH. Okay, like this. PH, getting ahead 1/2 when a coin is tossed. Okay, and it is read as the probability of the event. Now, probability of an event E, it is represented by number of event outcomes by total number of possible outcomes in S, that is the sample space to the numerator, just as I explained previously. Now let's consider a pair of die. Okay, when we have a pair of dice, what happens? Each of the outcomes in the sample space are random and equally likely. Okay, how do I define it? Let's say these are my 2 dice. Okay, now when we have 2 dice, what are the cases that it will give me? It gives me that there is one from one end and there are 6 other possibilities from the other end. So if in total, if I calculate what would be my sample space, it would be 6 from the first die, into 6 times in the other die. So always when we roll 2 dice, there are 36 possibilities. That is, the sample space is 36 for that case. Now, if you look at this, for example, probability for a certain case, it can be written as 2 by 16. Okay, there are 2 ways to get 6 and 4. Okay, one is 6 from this die and 6 from this die, or 4 from this die, 4 from this die. Okay, so that is how we have calculated this probability. Now, like this, if you see, there are so many possibilities, right? If you combine all of them, you will always see that there are 36 possibilities. Alright? Now, this is the probability model for a 2 die. Okay? You see, these are all in total 36 cases. You see, one common from one first die, and then 6 different possibilities, then 2 common. So if you match them all, you will find that they cover almost everything. Alright, so in sample space for 2 die, 36 is the sample space. Now each individual outcome has a probability of 1 by 36. Alright, now let's look into these deeper figures. Now similarly, for different cards also we'll get different cases. When we roll the die, we get different cases. Now on the basis of whatever we have studied, let's look into the examples. Okay, when we have 2 die, okay, one blue and one gray, okay, are thrown at the same time, write down all the possible outcomes. Okay, and what is the probability that the sum of the 2 numbers appearing on the top of the die is 8, 13 or less than equal to 12. Now you can write down the sample space. Okay, I need not write that, you know all the sample spaces of that, so you can do that. Okay, that's fairly easy. Now let's look into the question part. Okay, now the probability that the sum of the 2 numbers appearing on the die is 8. Now if I roll 2 dice, what are the possible factors to get 8? I can get 2 and 6 from 2 and 6, and 6 and 2, right? Then I can get from 3 and 5, 5 and 3, and I can get from 4 and 4, right? So these are 1, 2, 3, 4, 5 cases. So out of 36, I have 5 by 36 chance of getting this. Okay, now to get 13. Now if you see, maximum in both the dice, I can get 6, right? Combine them, you can get a maximum of 12 itself, right? So 13, it is 0 by 36, so it will be 0. 13 cannot occur, so this is impossible occurrence. Okay, so that is why the probability is 0. Less than or equal to 12. If you look at it, when 2 dice are rolled, the sum can either be 2, it can start with 2 and go up to 12, right? So the probability of this occurring is 36 out of 36 times. Okay, that will be 1. Okay, so it will occur, it will always occur. Okay, it is a certain thing that it will happen. That is why our probability is 1. Okay, now let's take another example. You see, this is the description of all the solutions that we have just had. Alright, now in the second example, it says that I need to find the probability of getting a head when a coin is tossed once. Also find the probability of getting a tail. Now when a coin is tossed, okay, what is the probability of getting a head? You see, let's draw the sample space. When a coin is tossed, these are the 2 things that it can happen. I can get a head or a tail. So these are my sample spaces. So my sample space is in the denominator. Probability of getting a head is 1 by 2, and probability of getting a tail is also 1 by 2, right? 50% chance of each of the things happening. Okay. Similarly, if f is the event of getting the tail, then also in that case 1 by 2 will be the probability of getting a tail, right? Probability of getting a tail 1 by 2. Alright, so that is all in this part of probability. Stay tuned for more videos. So guys, that was all in our part 1. Now in this, what did we learn? We learned the basic of probability. What are the different kinds of probability that we deal with, that is with coins, with deck of cards, and with rolling of a die. Now rolling of 2 dice is the most important phenomena among all of this. Now when individually each coin, each die or a deck of cards are quite easily to deal with. But when we introduce 3 coins tossed simultaneously or 2 dice rolled simultaneously, then the complexity of such problems increases. So that was all in our part 1 video. In part 2, we will look into the different kinds of probability that we have and the basic literature behind probability, how the basic literature deals with different situations and how each of them is represented mathematically. So stay tuned for part 2.